okay, just so I don't forget to do it this time. All right, so I got these documents. You want to start on number 11?
Sure.
Okay. What system? You've probably learned two systems for solving a system of linear equations. One is called substitution, the other is called elimination, right? Those two terms sound familiar to you?
No.
All right. Well, whenever we have two equations and two variables, first of all, let's start at the beginning.
My dad's calling too, so.
Hello?
Hey, David, it's not possible for today for you to put your phone on speakerphone so I can hear the lesson. For some reason, my Mac said that I'm under, I don't have the proper updates today from yesterday. So we can't get the sound out of the laptop, so I was wondering if I could get it over my phone.
I could call back if you have a speakerphone on your end. We can use.
Yeah, I got a speakerphone on my end, and then of course Patrick's got his headphones and his microphone on.
Well, will Patrick be able to hear it if I call your house number? What number should I call?
You know, if you want to just call 720-620-3388.
Okay, let me call that back on my Google phone. Now, you're going to have to go to the GoToMeeting and have him turn it on telephone instead of mic and speakers.
Okay, can you hear him through that, Patrick? You know what, David? Patrick can hear you through the headphones. Yeah, I'm not gonna make it any more complicated. I'm just gonna hang up, and if he's got any questions for me, he can ask.
Okay, I've got the record on today, so you'll be able to watch the session out.
Yeah, I don't want to complicate it more. So I've already screwed up enough time here, so I'll get off.
Okay. All right, Patrick.
Yeah.
All right. Let's talk about equations. If I told you that 3x equals 9, that's one equation and has one variable. We can always solve for it. What's x equal?
It would equal 3.
Okay. Now, if I introduce a second variable, and I say that's equal to 9, what's x and y equal to?
I'm not sure.
Well, there's an infinite number of solutions. In other words, x could be 1, y could be 8, x could be 2, y could be 7, x could be minus 2, and y could be 11. In other words, I could go on and on forever. So when you have two variables and only one equation, you don't have a solution. You have an infinite number of solutions. Okay? All right. One of the rules of math says that you can add or subtract equations. In other words, if I have x plus 3 equals 10, and I have x minus 3 equals 6, I can add those two equations. Well, that's 2x. 3 plus minus 3 is 0. Add the right side, I get 16. X equal 8. And you'll see that 8 works. Whoops. What did I do? Added the two equations. Now I have 2x equals 16, x equal 8. Well, the problem I made up in my head didn't go so well. So forget that. Let's go back to this problem we have. Well, hold on. Let me say one other thing. If I have two equations like this, a plus b equals c, and x plus y equals z, mathematics allows me to add equations. In other words, a plus b plus x plus y equals c plus z. Also, I can subtract any two equations. In other words, I could say a plus b minus x plus y equals c minus z. You with me?
Yep.
So I can add or subtract equations. Well, in this particular problem, my goal, there's two methods of solving two equations with two unknowns. In other words, as long as you have as many equations as you have variables, you're going to be able to come up with a solution. What we use is a process called elimination to solve this. What I want to do is I want to add or subtract the two equations and try to eliminate a variable. Well, if I add the two equations right now, I don't. I get 2x plus 4y equals 18. That doesn't do me any good. I can't go anywhere from there. However, algebra allows us to multiply this bottom equation both sides by any number I want. So I'm going to multiply it by 3. I have to multiply both sides by 3. See what I did?
Mm-hmm.
Okay. Now, I can still add that to that. In other words, I didn't change equation number 2. I just multiplied it by 3. Well, now what happens when we add the two equations? What do I get?
You get 6x.
No, when I add 3x to minus 3x, I get 0.
All right,
That's the
so-
key. In other words, the whole reason I multiplied this equation by 3 was such that I could eliminate a variable. That's why it's called solution by elimination. Now what do I get when I add the y's?
You get 15.
16. 18 minus 2.
Oh, sorry.
16y. I got to add the numbers. That's 32. Now I can solve it. Y equals 2. And once I have a solution for y, well, I can go back into any of the 3 equations that I have there and solve for x. Well, let's choose the simplest one, that one right there. And I'm going to substitute 2 for y, so I got minus x plus 6 times 2 equals 7. That's minus x plus 12 equals 7. That's minus x equal minus 5. That means x equals 5. So y equal 2, x equal 5 is a solution. Well, let's check. X equal 5, y equal 2. Well, does that work? Well, 3 times 5 is 15, minus 2 times 2 is 4, 15 minus 4 equals 11. It does work. That's called solving a system of 2 equations and 2 unknowns by elimination. Now, when do we use elimination? We use elimination whenever we have it in standard format. Remember, this is standard format. So if I have something like this, 2x minus 4y equals 10, that's standard format. And if I have another equation that says minus 2x plus 6y equals 4, how would I solve that?
When you use the process of elimination, or would you add them?
We would add the 2 equations, because in the process of adding them, the x is going to disappear. Notice that plus 2x added to minus 2x gives you 0x. Add the y's, you get plus 2y. Add the numbers, you get 14. Now we got a solution, y equals 7. Once you've solved for one of the variables, the other one becomes fairly easy. You just substitute in. So I'm going to substitute y equals 7 into this equation and solve it. So 2x minus 4 times 7 equals 10. That gives me 2x equals 38, x equals 19. So my solution is x equals 19, y equals 7. Now, in that problem right there that I just made up, I made sure that these two terms would disappear. In other words, I didn't have to do any manipulation of one of the equations first. But that's not usually the case. Usually, in the problems you get, like number 11 here, we have to manipulate one of the equations first. Let's look at number 12. And this telling you what the solution is and saying, is that a solution? That doesn't do any good. In other words, we don't need that. We can solve this all by ourselves without multiple choice or anything. Now, if I were, and I can also add equations. What I like to do on these is number them, like that. Now let's look at this. If I add or subtract these two equations right now, does any variable get eliminated? Just look at it and add the two equations and see if one of the variables disappears. What do you get if you add these two equations, Patrick?
What did you say?
What do you get if you add these two equations?
What do you get?
Just add them straight away.
All right, you get 8x, then you get negative 2y equals negative 12.
Negative 18.
Negative 18.
We're adding two negative numbers. Just add the two numbers and put that sign with them. Okay? Notice that when I added the two equations, I still have two variables. I can't solve this. I have one equation and two variables. There's no way to solve that. So, I can't solve this system of two equations by just adding them. How can I manipulate this lower equation number 2 such that when I add it to equation number 1, one of the variables will disappear? What could I do?
You times it.
By what?
3.
All right, so I'm going to rewrite equation 2. I'm going to multiply it by 3. That gives me 6x plus 3y equals minus 9. That's my new equation 2. Now, if I look at equation 1 and equation 2, what happens if I add those two together?
You get 0 plus
Hold on.
y.
6x plus 6x is 12x.
Oh, 12x. Okay.
I'm adding them. But the y's cancel. Negative 3y plus 3y becomes 0. And that was the whole purpose that we multiplied it by 3, was so that would happen. And what do I get on the other side here? Well, it's negative 15 plus a negative 9.
Negative 24.
Okay. So what's x equal to?
X equal to 2.
Negative 2.
Negative 2.
Remember, we're dividing a negative by a positive. Okay. Now, let's solve for y. Now, we have a choice. Let me erase that line. I can go into any of these three equations to solve for y. Let's pick the simplest one. What's the simplest one?
What'd you say? I'm sorry.
I can go into any of these three equations to try to solve for y, because I got to solve for both variables. At this point, I've only solved for x.
So the simplest one would be -3?
Well, the middle one, yeah. So how do I solve for x? How do I solve for y? If I've got 2x plus y equals -3, and I know what x is -2, so how do I proceed from there?
You take the -2 and then times by the 2x?
Well, times it by the 2. In other words, I substitute -2 for x. Still got the y. What's the next line here?
It'd be -4 plus y equals -3.
Okay, and then what's the next step?
Y equals -3.
I got to add 4. In other words, right now, 4 is being subtracted from y. Or a -4 is being added to y. So in order to get rid of that -4, I have to add 4 to both sides. Well, when I add 4 to this side here, a -3 plus a +4 gives me 1. So now I have both my solutions. X equals -2, y equals 1. And that's the way we solve all of these, is that process right there that we just did.
What's the first one you did? Did you do 11? Where is it?
Did 11, that was 12. We're going to work on 13 now.
Next one is 13.
Huh? Now remember, the goal here is to try to manipulate these equations such that when we add them together or subtract them, we'll be able to lose one of the variables. What can we do here? In other words, if I add these together, I get 5x plus 4y equals 21. It doesn't do me any good. So I gotta manipulate one of them such that afterwards, when I add them together, I'm going to lose a variable. Which one can I manipulate?
The top one?
Okay, I can actually manipulate either one, but if I'm going to manipulate the top one, what do I want to do with it?
You want to subtract it?
I want to multiply both sides of equation 1 by -4. Why? Because what will happen? I'll get, if I multiply both sides by -4, I get -4x minus 12y equals -60. You see that?
Mm-hmm.
In other words, this is the exact same thing as that. I haven't done anything to it. I just multiplied both sides by -4. It's the same equation. But the difference is now, because I've written it this way, and I'm going to call that the new equation 1. It's the same as the original equation 1. It's just written a little different. But now notice that if I add equation 1 to equation 2, my x disappears. That's what I'm looking for. So what is my answer? In other words, that's no longer in play. When I add these two equations, what do I get?
You get 0 plus -12y equals -6.
Okay, hold on. You make a very common mistake that people make. And that is when they see a y, they forget that there's a 1 in front of that. That's 1y. So if I'm adding 1y and -12y, what do I get?
-11y.
Okay. Add the numbers.
You get -54.
So y is equal to what?
Hold on. -54
What's negative 54 divided by negative 11? First of all, is it positive or negative?
It's negative.
Positive. Okay. Negative divided by negative is positive. Negative times negative is positive. So our answer is going to be positive. We're going to divide both sides by minus 11. So we get minus 54 divided by minus 11. That's the same thing as 54 elevenths. And that's the answer for y. Now, again, I need, in order to solve for x, because x got eliminated the first time through, in order to solve for x, I need to pick one of these equations, substitute for y, our known answer for y. I'll pick this equation. And now I got 4x plus 54 elevenths equals 6. And I can solve that. It's not super easy, but in other words, it's by introducing fractions, they made it harder. But we can still come up with a solution for x. And we've solved for x and y. Okay?
Okay.
You're noticing the pattern here?
Yeah.
Okay. Let's look at 14. Notice you just have to do the odds?
Yes.
Well, let's stick with the odds for the moment. However, it says use the graph to solve it. Let's talk about that for a moment. If I graph this first equation, well, it's easy enough to do. The x-intercept is where y equals 0, so the x-intercept would be at at negative 6. See that?
Mm-hmm.
The y-intercept, remember I'm doing this one, the y-intercept is where x is equal to 0, so the y-intercept is 3. So that's that line. That's this equation right there. Okay? These are both linear, so they're both straight lines. Now, if I graph this line here, the second one, well, let's see. If y is 0, x is 24, so the x-intercept is 24. And if x is 0, y is 6, so the y-intercept is there. Where do you think the solution comes? Right there. In other words, if I have two linear equations and I want the solution, graphically, it's where they cross. In other words, whatever the x and y coordinate are on that point right there is the solution to these two equations. And I can do it graphically. It's not the easiest way to do it. I mean, notice how much work I've had to put into it already just to graph it. And I still don't know the solution because I don't have grid paper and I don't know what the x and y coordinate are there. So let's solve it the way we just solved the others. As long as you understand what they mean by solving it graphically, that's okay. What's the easiest way to solve this? If we use elimination, how can I solve this?
Then you just add them.
Okay, what do you get when you add them?
You get 0 plus 6y equals 30.
Okay, so y equals what?
5.
Okay, now how do you get x?
Now you just eliminate the y, so that would be...
No, we don't eliminate the y. We choose one of the equations and we plug in the value we know y is equal. We now know that y equals 5. So in order to get a solution, let's choose the easiest one. That one's easier because the x has a positive sign in front of it. So plug in y for 5, or plug in 5 for y in this equation. And what is x equal to?
X is equal to 4?
Yeah, that's how you do it. In other words, it was much easier getting the solution by adding the two equations right out. We got the solution for y immediately, and it wasn't that hard to get it for x. So it was far easier solving these two equations by using elimination than it was by graphing. We can do it by graphing just to show you that you're going to get the same solution. Let me graph it on Wolfram Alpha. Wolfram Alpha is a great little math program. Let's see, we have minus x plus 2y equals 6. Minus x plus 2y equals 6. And the second equation is x plus 4y equal 24. X plus 4y equal 24. I put both of those into Wolfram Alpha. It's going to graph both of them on the same line, just like it did. And notice that it came up with the solution. The solution is right there, 4 comma 5. That's what we came up with, 4 for x, 5 for y. Well, if somebody would have graphed them for us, then sure, I could come up with the solution immediately. It's key to understand that the solution is where these two things intersect. But that's not always the best way to solve two equations and two unknowns. As you can see from this example, it was far easier to solve them by adding them than it was by graphing them. Let's see, should we go to the next page? Did we cover everything we needed to cover on this page?
We missed 15, but I think I can get it.
Let's do 15. Thank you for reminding me that. I didn't realize we missed it.
Let's do 15.
Yeah, definitely do 15.
15, we got time.
Yeah, we'll do it.
You going to do 15? Yeah,
Uh-huh. Okay. Now, clearly, when you look at this, you can see that nothing's going to happen if I add them together or if I subtract them. You don't always have to add equations. Sometimes you can subtract in order to eliminate a variable. What can I do to this equation such that I can eliminate the variable after I do it?
I don't know.
Yeah, if I add them, I get minus 12x plus 6y equals 2. That doesn't do me any good. In other words, I get minus 12x plus 6y equals 2. I can't solve that. I've got to be able to eliminate a variable. That's why it's called elimination. Well, no variable gets eliminated, but what can I do to one of the equations such that then a variable will get eliminated? What could I multiply the bottom equation by?
5.
There you go. So this is equation 2. I'm going to change equation 2, multiply this by 5. What do I get?
What? Oh, you get 0.
Hold on, just multiply it by 5 first.
All right, you get 15.
15x. Keep going.
And then the other one you get 5y.
minus 5y equals what?
Hold on, equals 5.
Okay. That replaces my original equation 2. Now, I've got these two equations. Now what can I do to eliminate a variable?
Subtract.
Add them.
Add.
In other words, if I got a minus 15 and a plus 15. If I add those together, I get 0. That eliminates the x variable. What is plus 7 plus minus 5?
That'd be 2y.
Equals 6. So y equals 3. Now what?
Now you plug it in to solve for x.
Which one?
I'd say the easiest would be the bottom one, second one.
Yeah, because it has a positive coefficient already. So 15x, what?
Minus 5 times 3 equals, would it be 5?
In other words, it's this equation here we're plugging into. Okay, so now all we got to do is solve that. And we're in like Flint. That's 15x minus 15 equals 5. That's 15x equal 20. That's x equal 4/3. 20 divided by 15 is 4/3. So there's our solution. X equals 4/3, y equals 3. Notice we're doing exactly the same thing on every one of these. We're trying to get one of the equations manipulated so that a variable will disappear when we add them together. Now, that's not the only way to solve equations. Well, let's just cover the other way that you're bound to be learning at the same time. And that is, let's say I have two equations and they're not both in standard format. One of them is already defined, like that, y equals 5. Well, now, we're not going to solve this by elimination. We're going to solve this by substitution. Remember those two words, substitution and elimination, because those are the two primary ways we solve two equations with two variables. If this is the two equations, the reason it's called substitution is because I'm going to substitute this for y in the first equation. So I got x plus 5 equals 10. Well, that tells me x equals 5. So x equals 5, y equals 5 is the solution to both of those. Notice I didn't use elimination. I used substitution. And the reason I used substitution is because one of my equations was already fully defined. Even if this would have said y equal 4x, now I have two equations, two unknowns. Don't like solving them by elimination because it's not in standard format, but I can certainly solve them by substitution. I'm going to go up here in the first one and I'm going to say x plus, instead of y, I'm going to write 4x equals 10. That means 5x equals 10, x equals 2. So those are the two primary methods of solving a system of equations. Are we done with this page? Can we go to the next one or not?
Yes.
Okay.
We're done.
Let's see. I think 90 is the next one.
I guess.
We want to do just the purple ones?
Yep.
Graph and check to solve the linear system. Well, let's check that solution. Hold on a second. So this is bizarre. So 21 is the answer to 20? No. I'm confused here.
We're supposed to do every third. Those arrows are just pointing to which ones we're supposed to do.
It's 21, 24, 27, 30, 33.
All right. Well, 21 is confusing because it's the answer. I was confused by the fact that this orange arrow pointed to it, but 21 is like a trick question. In other words, they're giving you two equations and they're saying, check to solve the linear system. Well, the solution is y equal minus 6, x equals 6. Now, let's talk about graphing that since they say to graph it. Y equals negative 6. What kind of line is that? Horizontal or vertical?
Vertical.
Horizontal. In other words, y equal negative 6 means that no matter what x is equal to, y is equal to negative 6. Okay? X equals 6. Is that horizontal or vertical?
That's horizontal
That's
or vertical.
In other words, they're opposite one another. So that's that line there. Well, there's the solution where they intersect.
You draw the graph in your homework.
Notice that where they intersect is y equal negative 6, x equals 6. So the solution is what they gave us to begin with. So that's not much of a problem. Let's look at 24. We have 5x plus 4y equals 16. And then we have y equal negative 16. How are we going to solve this? It tells you to solve it by graphing, but that's not what we want to do right now. In other words, I could certainly graph that, and wherever they intersect is the solution. But let's try to solve it algebraically, since we've been practicing that the whole time. So am I going to use a method of substitution or the method of elimination?
Elimination.
No, substitution. Why? Because one of the equations is fully defined for one of the variables.
Oh, I see.
In other words, we have a y equals. Or if we had an x equal, we would use substitution. Because I can immediately substitute that into this. So what's my equation number 1 rewritten with the substituted variable for y?
It'd be 5x plus 4 times 16
4
equals
times minus 16?
Sorry about that. Equals 16.
4 times minus 16. You can't,
Sorry about that.
you can't drop the negative signs here. It's going to change everything if you do. In other words, bringing forth a positive or a negative sign is every bit as important as the number. We won't get it right if we drop the sign. Okay? So simplify this for me.
All right, let me just do that real quick.
It's okay if you want to use a calculator. And there's no problem using a calculator when you have a double-digit number. I don't particularly want or need students to be able to do multiplication of 1 digit by 2 digits. That's okay to use a calculator. What you need to be able to do in your head is 1 digit by 1 digit. You need to know all of those. You need to know your multiplication tables perfectly. Not 90% perfectly, but perfectly. Because if you only knew it 90% perfectly, you'd start using a calculator to check yourself every time. And then the moment you do that, you're going to forget how to do those multiplication tables. That's why so few students today know their multiplication tables, is because we live in a calculator age. Everybody has one, and everybody wants to make sure they get the answer correct, so they use the calculator. Unfortunately, after a while, they forget how to do the math, the arithmetic. So what's 4 times a negative 16?
Negative 64.
Okay. And I could write plus a negative 64, but that's the same thing as writing minus 64. And that's how I want to write it. What's the next step to solving that equation? What's the next line?
Oh, hold on.
What do I need to do? If I'm trying to isolate x.
You subtract 5.
No. First of all, we've got 64 being subtracted, so we got to do the opposite of that first by adding 64. So I'm going to add 64 to both sides. That gives me 5x equals 80. And then what?
Then you just divide.
By 5. In other words, now we got 5 multiplying x. So the way to get rid of the 5 is to divide by 5. Always do the opposite of what it's doing, which means x is equal to 16. Well, one of the original equations was y equals minus 16. So there's our solution, okay, that we solved algebraically. We solved it by using the method of substitution. Well, they wanted us to solve it graphically, so let's do that also. The way I'm going to do it graphically is I'm going to graph both lines. What's the easiest way to graph that?
You just do 16.
No, to graph equation 1. 5x plus 4y equals 16. That's a linear equation. It's a straight line. But the easiest way to do it is just to graph the x and y intercepts. Remember, the y-intercept comes when x is 0. So the y-intercept's got to be 4. You see why? In other words, if I make x 0 and solve this equation, I get y equal 4. That tells me that the equation of that line goes through that point. And then the x-intercept is where y equals 0. So if I let y equal 0 and solve this, I get x equal 16/5, which is right about there, slightly more than 3. Okay? So that's the equation of that first line. The equation of the second one is y equal negative 16. That's a horizontal line going through that y-intercept. There's our solution right there. Notice that because I don't have grid paper, we can't read what that solution is. I certainly can tell that y equals negative 16. That's part of it. X is clearly positive, but we don't know what it is. That's because when you solve two equations graphically, if you don't have grid paper, you don't really know what the answer is. If you have grid paper and it's a whole number, you can probably read it properly. But solving equations graphically is not the best way to do it because it's hard to read the solution. When we did it algebraically, we got x equals 16, y equals 16, and that's correct. In other words, the x value there is 16. Although I couldn't tell it from the graph that I drew. But the algebraic solution always trumps the graphic solution. In other words, if you've done the algebra right, then whatever solution we come up with algebraically is the solution. It just so happens you can get it a different way by doing it graphically also. All right, let's look at this one. Remember, the secret to solving two equations and two unknowns is to whoops, 14, is to turn it into one equation and one unknown. Okay? Well, if 7y equals this, and 7y also equals this, then I can say that that equals that. Has to. They're both the same y. So I'm essentially doing this by substitution. I'm not going to do it by elimination, although I could. Let's do it a multiple number of ways. Let's do it by elimination. Even though it's not in standard format, it happens to be in perfect format for doing elimination. What do I have to do to eliminate one of these variables?
You have to minus it.
Well, I could do that. I'll eliminate y if I minus it. I could also add it and eliminate x. Adding's a little easier than subtracting. It's a little more certain that you're not going to make a mistake. So let's add it. 14y equals, the x's disappear, and this becomes 56. Notice how easy the solution is to add them together. Immediately we get y equal 4. Now we can plug that back into either equation and solve for x. So elimination works great. Let's try subtracting them. What happens if I subtract them?
What happens if you subtract them?
In other words, we haven't done that yet. We've only added equations. Well, it's also legal, mathematically, to subtract equations. Well, notice that if we happen to subtract one from the other, the y's disappear. So I'm going to subtract the bottom one from the top one. That leaves 0. What's this? What's minus 14x minus 14x? Remember, I'm subtracting them.
Wouldn't that be negative 28x?
And what is 42 minus 14?
It is up.
28. Now what? What's the next step to solve this?
Oh, what's the next step?
Yeah.
All right, then you just
Trying to isolate x.
so then you add 28.
Subtract 28. Right now, 28 is being added. So I got to do the opposite of that. I got to subtract 28 from both sides. That leaves this. Now what?
Then you just divide.
By minus 28. Now what does x equal?
X equals 1.
Exactly. So I was able to solve for x by subtracting the two equations, and I was actually able to solve for y by adding the two equations. So that one was a particularly easy one because it actually allowed me to solve for both variables by doing the same, while adding them and subtracting them also. Patrick, I'm going to have to go because I have a 5 o'clock. But hopefully that was helpful to you.
It was.
How to handle two equations and two unknowns.
All right, thanks.
All right, I will talk to you next time.
Bye.
Bye-bye.